So the background to the work is that obviously we become very reliant on plastics for many of our everyday life applications. And in principle, have many great properties, which is why we use them. But they have two really fundamental problems. So the first one is that they are sourced from fundamentally non-sustainable feedstocks, essentially oil-based feedstocks. And the second problem is that they have very poor degradability characteristics, and therefore they accumulate in ecosystems. And so we were inspired to try and use some of the fundamental science that we develop here at the university to try and see if we could develop replacement materials which wouldn't suffer from these two fundamental problems. And the big problem we have is we use plastics for so many things in our everyday lives, but of course plastics in many cases really degrade very poorly, and so therefore they're present in the environment for hundreds, in some cases thousands of years, and accumulate. So we really need to find a way to generate materials which are plastic-like, but which don't have this fundamental disadvantage. So what we've done is we've developed a new type of material, which looks like plastic, feels like plastic, but it's not plastic. It comes from plants. So we take plant-based molecules and we reassemble these molecules in a way which is actually very similar to spider silk. And this allows us to create these types of materials. At the event, I will talk about the fundamental science research that underpins this work that we've been carrying out at the university here. I will then talk about how we've taken this fundamental research out of the lab and started a company called Sampla, which develops products which aim to replace plastics in a broad range of applications. And then I'll share some thoughts finally on how I see the future of sustainable materials and the interface with deep tech. I look forward to sharing more of this story and connecting on the 28th of February in London.